Standard 12 Commerce, subject statistic, chapter number 3, that is normal distribution. Last time that we completed properties of normal distribution. And right now we are going to discuss about the next topic, that is theoretical part, and that is properties of standard normal distribution. So many of the points are included in already that we discussed in normal distribution. That point is repeated over here. So let us discuss one by one all the points and then example related to it. Yes, some important properties of standard normal distribution are as under. Number one, it is for a continuous random variable. Okay, so same as number one. So it is for continuous random variable. Okay, so two types of variable is there, discrete and continuous. So for discrete, chapter number 2, probability that we have to find out. But here, for the continuous random variable, standard normal distribution that we have to use. Next, number 2, for this distribution, mean is equal to always 0. Okay, so here number 2, that is mean is equal to always 0, and that is mu is equal to always 0, and standard deviation, that value of standard deviation is always 1. So this is the second property. For the distribution, mean is 0 and the standard deviation is 1. Number 3, the distribution is systematic into z is equal to 0 and its skewness is also 0. So third property is that we can see z is equal to 0 and that we always write. Okay, when we draw our bell shape diagram, whatever the middle line is there, that we assume z is equal to 0. So that is also an important part. Number 4, the probability curve is completely bell shaped and approximately to x-axis. Okay, so here the probability that we have to use bell shape. Okay, and it is parallel to x-axis. Okay, but it is never touched to x-axis. See, many of points are there, those were already included in our last particular lecture. Next, number 5, the approximate value of first quartile of standard normal deviation is minus 0.675 and the third quartile is plus 0.675. First quartile, that means Q1 is equal to minus 0.675 and third quartile, that means Q3 is equal to plus 0.675. So if we have to find out Q1 and Q3, easily we can get the value. Next number 6, for this distribution, quartile deviation is equal to 2 by 3 and mean deviation is equal to 4 by 5. That we already discussed. That is quartile deviation QD is equal to 2 by 3 delta and mean deviation MD 4 by 5 delta. That we already discussed in our last particular example, last particular theoretical question. See, this one is very important. Okay, because in our next example it can be asked, find quartile deviation, find mean deviation. So at that time we have to use this formula. Okay, so it is important one. Okay, so here the quartile deviation, the value of quartile deviations is equal to 2 by 3rd delta and the value of mean deviation MD is equal to 4 by 5 delta. Okay, so this formula is that we have to use when you are calculating example. Okay, next one, important area under the normal curve is as below. So important area is there. Let's see. Number 1, total area under the normal curve is 1. So as we know that total probability, so here total probability is equal to 1. That's why we have divided that into 0.5 and 0.5. 0.5 from the left hand side and 0.5 for the right hand side. Okay. Both the sides are perpendicular, that is z is equal to 0 to 0.5, because left hand side is 0.5 and right hand side 0.5. Next one, the area under the curve between the perpendicular lines z is equal to -1 to +1 is 0.6826. Okay, thus this is the value, and that is area under the normal curve between the perpendicular line z plus or minus 1. It means that the value of plus minus 1 is equal to 0.6826. Same as number 2, the area under the curve between the perpendicular line z is equal to -2. So here two things that we have to do: the value of z and the value of probability. Okay, so here the value of z either plus or minus 1, the value is 6826. Okay, same way the value is plus or minus 2, the value probability is 9545. Okay, and either value is plus or minus 3, probability area is 0.9973. Okay, so this is directly value given. So if we have to find out the value of z 1 2 3 simultaneously, we can put the value 0.6826 for the 1, for 2 9545, and for 3 0.9973. So this value that we can directly use in our example. Next one, the area under the curve between the perpendicular line z is equal to -1.96 and plus 1.96 is 0.95. So here minus or plus 1.96, the value is 9500. Okay, so this value is that it is directly given, and that we can use in our example. Okay, when we calculate the example, it will be more suitable for the understanding. Okay, and next, value of minus 2.575 or plus minus 2.575, the value is 0.9900. It means that 0.99. So plus minus 2.575 value is 0.99 and plus minus 1.96 value is 95. So this is that we can see that this is the key point when we were calculating examples. This is the key point, okay, which is helpful to calculate the example. Okay, so now some other theoretical questions is also there. It should be noted here that the probability distribution of standard normal variable z is a distribution for normal variable with mean 0 and variance 1. Okay, so already we discussed mean is equal to 0 and standard deviation 1. The square of 1 is equal to 1. So variance is equal to also 1. Okay, next one. Z is called standard score or Z score, and it is dependent on unit of measurement. So Z score is always depend on unit. See, this is the unit, Z unit. Okay, so depend on Z unit, we can find out the value of Z score with the help of table. Okay, last page of your textbook is most important table when we are calculating this type of examples. Next one. We have seen earlier that when a value of normal variable x and value of parameters are known, then the corresponding value of z score is obtained, and by using the table of standard normal variable, the respective probability can be obtained. Now, it is probability is known that the determined value of z score. We shall study the following illustration. Okay, so here now with the help of that illustration we can understand. Okay, so okay, fine. So here example number 6. If the probability that the value of standard normal variable z lies between 0 and z score is 0.3925, then obtain the possible value of z score z1. Okay, so two values given. What is the value of z? So z is equal to 0 to 0.3925. See, whatever we calculate up to example number 5, value of x is given. On the basis of x, what we are finding? Z. But here directly probability of z is given. It means that whatever we find out as the answer, that answer is given in question. Okay, so reverse. We have to find out reverse thing. So with the help of that diagram, Bell-shaped diagram, we can find out. Okay, so basically this is our Bell-shaped diagram. Z is equal to 0, minus infinity and plus infinity. Okay, what is the value of z? 0 to 3925. Either it is plus or minus, both possibility can be there. Okay, so here can be taken as a plus. So here z is equal to 0 and 0.3, or here we can say that is 0.3925. Okay, so this portion value is given. Now what we have to find out? We have to find out this value. We have to find out this value. It means that 0 to 0.3925. Okay, so what is the exact value? What is the exact value which probability is 0.3925? Okay, so simple. Open the last page of your textbook. Okay, and now whatever we find, on the basis of answer we have to find out question. Okay, so let's see 3925. Okay, so 3925. Okay, so it is given. Let's see, pick z square, z in z line. Let's see 1.2. Okay, and 1.2 then in 4 thing. Okay, so that we can see 0.3925. Okay, where it is given again from z value 1.2. Okay, from z value 1.2, and we have to move from here 0.4. Okay, so here we can see that the value is 1.24. Okay, easy example. On the basis of answer, we have to find out question. Okay, so here that we can see that either it is minus or plus. Okay, so here let's see. Suppose that is z1 is equal to positive. So what is the value of z? So z1 is equal to 1.24. So this will be your answer. Okay, it is given, that is p, probability p. Okay, that probability p 0 to z to 0.3925, and it is value is 1.24. Okay, so here we can see that the value of z1 is equal to 1.24. Okay, so it's a positive sign. Now if you find out as a negative, okay, so suppose it's a negative, so here that is suppose z1 is negative. Okay, so negative, that means we have to draw again bell-shaped diagram. Okay, fine. So this is z is equal to 0. The value of z1 is which side? Negative side. So this is minus infinity and plus infinity. So this one is z1, that is this portion. Okay, and value is negative. Okay, so portion value is 0.3925. So here we can see that p is equal to z1 to 0 to z is equal to minus 0.3925. Okay, so value is minus 1.24. So Z1 is equal to minus 1.24. Okay, so two types of value is there, either 1.24 in plus or either 1.24 in minus. So what we learn in this example, on the basis of probability area, listen me, on the basis of probability area we can find out the